Alright, hello everyone. I hope you guys are doing good. So today I somehow managed to wake up early, and so I'll be trying out this Leetcode Weekly Contest 291. So I'll try to be as quick as possible and let's see how it goes. Here we go. We have the first problem. Alright, so you are given a string number representing a positive integer and a character digit. Return the resulting string after removing exactly one occurrence of digit from the number such that the value of the resulting string in the decimal form is maximized. Okay, so we need to remove the rightmost occurrence, I think. The digit occurs at least once in the number. Yeah, that makes sense. Okay, so we just have to remove the rightmost occurrence according to me. Yeah. So we have int n string s is equals to number and n is equals to s dot size I for I is equals to n minus 1, I is equals to 0, I minus minus. So if s of I is equal to digit, what we have to do is we just have to make another string answer. What we'll do is answer is s dot sub str from 0 to I plus s dot sub str I plus 1. And we'll return answer, and also we have to break out here. I hope this would do my job. For I is equals to 2, yeah, this should probably do the job. Let's just try to run it. Let's see, 12, 1, 2, 3, 51. Oh wait, so here the output is 2, 3, 1. That's weird. So do we have to remove the leftmost digit or the rightmost digit? That is the question. Maybe we have to do something like this. Answer is equals to max of answer. And this. Currently answer is equals to this. And we should remove the break statement, obviously. Okay, let's submit this. Right, let's move on to the second problem. So we have an integer array cards where cards of I represents the value of the ith card. A pair of cards are matching if the cards have the same value. Return the minimum number of consecutive cards you have to pick up to have a pair of matching cards among the picked cards. Okay, so we just have to make an adjacency list and find the minimum difference. Yeah, that makes sense. So let's say capital N is equals to 10 to the 6, right? So we build an adjacency list, size n plus 1. small n is the size of cards. Adj of cards of I dot pushback I. So now we just need to remove everything in between. So let's initialize answer by a very large number, let's say 1e9. And finally we go over all the elements. From 1 to n. So we calculate the size of its adjacency list. And then we go over all the elements and take the minimum difference. Answer is minimum answer adjij plus 1 minus adjij. So if answer is equal to 1e9, then answer is equals to minus 1. So that should do my job ideally. Let's see. So we are getting 3 here, which should not be the case. Let's see why we are getting 3. Okay, so I think I have read the problem wrong. So we have to return the minimum consecutive. Okay, so we have to include both of them. So there should be a plus 1 here. Let's see. Four and minus 1 looks good. Let's submit. Okay, so we are exceeding time limit. That is strange. That is really strange. Wow. Okay. The time complexity seems fine to me. Okay, so let's try something else then. So let's try to use binary search. I mean, this also has kind of the same time complexity, but I don't see any reason why we should get a TLE here. Maybe they want to keep a map instead of an adjacency list. So let's try to do something like this. So we go in this map. So this definitely is less than 10 to the 6. Let's see. 4 and minus 1. Okay, let's try to submit this. I don't know why this happened. Okay, so we are given an integer array nums and two integers k and p. So we have to return the number of distinct subarrays which have at most k elements divisible by p. Okay, let's see. So we can say that a number which is divisible by p, we can denote it by 1, otherwise we can denote it by 0, and we just need to find the subarray with the maximum sum, right? Oh, we have at most k elements. Okay, so that's cool. We can just use binary search for that. Okay. Okay. So if nums of I modulo p equal to 0, then nums of I is equals to 1. Otherwise nums of I is equals to 0. Then we can build prefix sums. And then we can do binary search on the prefix sums. So prefix sum of I is prefix sum of I minus 1 plus nums of I minus 1. Now we just have to do binary search. Okay, at most k. Yeah, so that can still be done using binary search. Okay. So j is equals to upper bound of, so basically what we want to have is p sum of j minus p sum of I to be strictly greater than k. So p sum of j should be strictly greater than p sum of I plus k. Sorry, p sum minus p sum dot begin. So this will give me the index, and all that I have to do is answer plus equals to j minus I and return answer. Let's see. The servers look quite busy today. I'm getting 15, which is wrong here. Let's see why. So let's try to output I and j. Okay, so let's see what happens. Yeah, so for 1 I'm getting 6, which is definitely wrong. Okay, what might be the reason here? Let's see if I'm calculating these prefix sums right. One, 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 2, 3. Yeah, that makes sense. Oh, this should be I minus 1. Yeah, that sounds good. Well, now I'm getting 14, which is again wrong. Okay, let's see why. Yeah, so with 1 I'm getting 5, which is correct. With 2 I'm getting 6, which is again correct. And with 3 I'm getting 6, 4 I'm getting 6, 5 I'm getting 6. So 1 plus 2, 3, plus 3, 6, plus 4, 10. Okay. Oh, I see. So the problem here is that we are supposed to count the arrays depending on the numbers present in them. So we don't have to differentiate between the multisets, and that's okay because the length of the array is small. Okay, so we have to have a set here. Okay, so we don't even need binary search probably. Yeah, we don't even need binary search. Hmm. We can just keep a counter. So count plus equals to nums of I minus 1. Sorry, nums of j minus 1. And if count exceeds k, then we break. Otherwise, we push it into our vector. And we insert this vector into our set. Answer is the size of the set, right? Now we are getting 11. 11 and 4. Okay, so why do we have 4 here? Let's see. I see. So let's create a duplicate array. Yeah. And instead of nums of j minus 1, we will check with a of j. Yeah, now it seems fine. 11 and 10 looks good. Let's submit. I hope I don't TLE. It is n square log n, and I TLE. Well, I don't know how this thing works at Leetcode and what are the time limits, but they ought to be really strict. Like the total number of subarrays is 400. 4 into 10 raised power 4, and then I just check the distinct out of them, so that shouldn't be TLEing definitely. So let's do something like this. Instead of a set, let's take a vector. And push this. And then we sort V. And so we have this unique function. I don't remember the exact syntax. Yeah. So this will do my job. Okay, hopefully this is going to work. and hopefully this won't TLE. Okay, let's take the chance. Still TLEing, I guess. Yeah, I don't know, let's look at the last problem first. So the total appeal of a string is the number of distinct characters found in the string. For example, the appeal of this is 3. Given a string S, return the total appeal of all of its substrings. Okay. Yeah, this one seems doable. So we need to return the total appeal of all the substrings. So let's just say for any substring we count the contribution of the leftmost occurrence of every character. Okay. Yeah, so for let's say we have an A, so the contribution of A will be 1 for every substring until we find an A to the left, and it will be 1 for every substring to the right of it. Yeah, that makes sense. Yeah. Int nij, n is equals to s dot size. Again, let's make this adjacency list. Alright, so we have this list ready with us. Now we can easily binary search on this. Okay, now let's iterate. So j will be the lower bound, adj of s of I minus a dot begin, comma adj of s of I minus a dot end, and the index I. No, we don't need this. So they will be the value. Maybe something like this. So if j, so if this iterator, we have this value L which we need to find. So if this iterator is equal to the first element, then we say that L is equals to 0, else L is equals to, else what we can do is we can do it minus minus, L is equals to star of it, L plus plus. Okay, so then every element from L to I is to be counted. So answer plus equals to, let's define everything as long. So answer will be plus equals to I minus L plus 1 times, so this is where the string is starting, and it can end at anywhere from n minus 1 to I, so that would be n minus I. So hopefully this is going to work. Let's see. So we are getting runtime error. 28 here, which is seems correct. Let's run all the other test cases. 28 and 20, both of them seem correct. Okay, let's submit. So this is done. Now only the third problem is left. I don't know why I'm getting a TLE here. So how else can we find the number of distinct subarrays which have at most k elements divisible by p? We naively find out all the subarrays which have less than or equal to k elements divisible by p, and then we find the number of unique elements. I don't see why this is not working. Okay, let's see how we can optimize this. So we have to look at every subarray, definitely. Nums of I is also up till 200, so maybe we can do something from that. How many people have solved this problem? A lot of people. So let's try to do some kind of DP here. Maybe that is the intended solution. Let's not do any of this. Let's denote by dpij number of distinct subarrays up till I which end at j and have less than equals to k ones. Okay. Now what? Hmm. Maybe we have to look at subarrays of size 1, then 2, then 3, and so on. I don't know what's going on. If you look at elements which are divisible by p only, then what happens? The total number of subarrays at max is going to be 4 into 10 raised to the power 4. Hmm? A lot of people have solved this, so it shouldn't be very complicated, definitely. Hmm. can look at everything ending at a particular index. And how to avoid duplicates. So using a normal set is tailing. Maybe let's just do something like this. Let's just do this naively. Still looks off, and no, doing it naively will be problematic. Yeah, doing it naively won't be good. Or maybe we can try. Okay, what's the harm? Let's just try. So if not found, then only you push it. Then answer is just v dot size. This is still probably going to tally. Let's submit. Well, I don't know. I really don't know what else I can do here. Okay, maybe I can optimize it. So previously it's true, and we do this check only if previous is true, right? Right, and if not found, we do previous is equals to false, and this is a slight optimization. Okay, let's see. It's not helping. Oh my god, I've had so many penalties. Let's try to take a set also. Hmm. Yeah, if pref. Okay, now this is the best I can do. Well, I don't know. Okay, so let's just end the recording here first and